Okay, so let's go ahead and find the inverse. So that would be, what happened? Oh, yeah. I'm sorry. No. Okay, so y equals 4 minus x over x. So this one is a little trickier because notice that we have x in two different places. So both of these are going to change to a y. And this is going to change to an x. So what we end up having is x equals 4 minus y over y. So with y in two different places, we have to solve it. So our first step is going to be, we're going to multiply both sides by y. Because when I multiply both sides by y, that's going to cancel out my fraction. So I'll have xy equals 4 minus y. And then you want to bring your y's on the same side of the equation. So see how we have a y on the left and we have a y on the right. We need them to be on the same side. So I'm going to bring this y over. So in order to bring it over, I need to add it. So when I add the y, that gives me xy plus y equals 4. Now that they're on the same side, we can factor out a y. And when you factor the y out, what do you think we have left when I factor a y out of these two? X plus 1. Good job. So we have y times x plus 1 equals 4. So our last step is to divide by the x plus 1. So our inverse equation is 4 over x plus 1. Okay, so now we're going to start 5-3. 5-3 is solving equations and graphing. So we're going to do solving today and graphing tomorrow. Quiz is on Tuesday. 5-3 is exponential functions. So we're going to solve exponential equations and graph exponential equations. Okay, so let's go ahead, and I'm going to skip over some of these questions, but we'll do a couple of them. An exponential equation is just an equation that has an exponent. So we're going to solve questions 1 and 2. Now, on this quiz, for your exponential equations, you will be able to rewrite them with the same base. Rewrite with the same base. So you can drop it. So there's two different types of exponential equations. Some exponential equations require the use of a logarithm, but that's not on the quiz. Now, it will be on the test, but it's not on the quiz. So your quiz is going to focus on equations that can be rewritten with the same base. So for this first one, this is pretty basic because x is not a part of your exponent. So x equals 4 to the third. So this is honestly already solved for you. X equals 4 to the third. And what is 4 to the third? 64. Okay. Question number 2. This is more like it. So X is in our exponent. We need to rewrite this with the same base. So you need to figure out 5 to the what power is 125. So don't say it out loud. See if you can figure out how to rewrite 125 with a base of 5. So if we can do a rewrite, we can drop it. So 5 to the what power is 125? Third. 5 times 5 times 5 is 125. Now that we have the same base, they have to be the same base. So if this was a 5 and this was a 3, we can't drop it. Or if I'm talking about the base. If this was a base of 5 and a base of 3. But because we have a base of 5 on the left and right, we can drop the base and set our exponents equal to each other. So our final equation or answer is just x equals 3. All right, let's go ahead. I'm going to skip around a little bit. Let's look at these two. Let's look at I'm trying to find ones that I think are more, on the lines of what we're going to see on our quiz. So let's look at these two, 7 and 8. So again, the goal is to rewrite it with the same base. So we have a base of 5. So we have 5 to the negative x. And then don't say it out loud, but see if you can figure out what my exponent has to be. So we need to find the exponent that I can put to a 5 in order to end with 625. So what's the exponent? 4? Good. So now we have the same base. We can drop the base. So we have negative x equals 4. So we have to do one more step before we can be finished. And that's get the x by itself. And we do that by dividing both sides by -1. So your final answer is x equals -4. Now, because both sides are fractions, there's a couple different ways to do that. Whenever you have 1 over a number, that means your exponent is negative. However, both sides are fractions, so we can actually rewrite this using the base 1 over 9. So what do you think my exponent has to be? To get from 1 over 9 to 1 over 81, what's my exponent? Not 9. Wait, who? Not -9. 2. 1 over 9 times 1 over 9 is 1 over 81. So 1 over 9 to the power of 2 is equal to 1 over 81. So see how we have the same base? We can drop it. So x equals 2. The other ones were a little bit too easy. So we need to rewrite 2 and 8 with the same base. 2 is the lowest we can go on our base. So this side here, we don't need to change, because I can get to an 8 by multiplying 2 over and over again. So only the 8 needs to be rewritten. So this side is going to stay. But what does 8 become? 2 to the what power is 8? How many times do you have to multiply 2? And if you're not sure, you can use your calculators. It's 3 times. So the biggest mistake is students will say 4 because 2 times 4 is 8. But you have to remember that this is not multiplication. This is an exponent. So it's 2 to the power of 3. 2 times 2 times 2 is 8. So this 8 is going to change to 2 to the third. But notice that we had a binomial. So that needs to be written in parentheses. So now we can drop our base. So the 2 can drop. And go ahead and solve this equation. This becomes just a basic algebra 1 equation. You have to distribute the 3 and solve it for x. So your final answer, leave it as a fraction. Who got 13 over 3? And that would be your answer. All right, I'll give you a second to copy that down, and then we'll work through number 10. But I'll have to erase number 9 because I wrote kind of big. Now, for question number 10, you have to rewrite both sides because I cannot get to 32 with a base of 4. So if you use your calculator and you do 4 to the first, you get 4. 4 to the second is 16. 4 to the third is 64. So we actually have to rewrite both sides. We have to go down. So what base do you think I'm going to use for 4 and 32? 2. So for the 4, 2 to the what power is going to give you a 4? 2. So this becomes a 2 squared. Write that 5x plus 7 in parentheses. And then on the right, 2 to the what power is 32? 2 to the 5th. So we actually have to distribute on both sides. Now we have a base of 2 on both sides. We can drop the base. So we have 2 times 5x plus 7 equals 5 times 3x plus 1. All right, take a moment, try to solve it on your own to make sure you're getting the right answer. This is a good quick review on how to solve an algebra equation. Distribute both sides and solve it for x. All right, so I'm going to distribute the 2, so that becomes a 10x plus 14. Distribute the 5, and that gives you 15x plus 5. I'm going to subtract the 10. You could also subtract 15x. So that gives you 14 equals 5x plus 5. And then let's subtract the 5. And that is what? 9 equals 5x. Divide by 5. Who got 9/5 as their answer? If you did, and we on the money, we good. Let's do a couple more. So the name of the game for the quiz, now after the quiz, we're going to do some harder exponential equations, because sometimes you can't come up with a common base. So not all numbers share a common base. And then that's where we have to use a logarithm. But on the next quiz, every number can be written with a common base. So we're doing the easier exponential equations first. And then after the quiz, we'll do the harder ones. Okay, let's go ahead and look at numbers 11 and 12. 11 is actually pretty basic because it already has a common base, so we can do it. So go ahead and solve number 11. You already have a common base. See, if the bases are the same, you can drop it. You can drop the base. And you just have to solve x plus 1 equals 3x minus 4. So you can just solve that for x. So we subtract the x. We get 1 equals 2x minus 4. Add the 4. So 5 equals 2x. Divide by 2. 5 over 2 equals x. Who had that? All right. So now let's look at number 12. Number 12 is a little bit more like it. So this is what I was saying here. Because it's a fraction, we only have a fraction on one side. This just tells me that my exponent on the left is going to be a negative. So we know that 4 squared would be 16. But if it's 1 over 16, it's a negative 2. So this side is going to be rewritten. We can still write it with a base 4. But it's 4 to the power of negative 2. 4 to the power of negative 2. If your exponent is fraction, if your exponent is negative, then that's how you get your fraction. So that equals 4 to the power of x minus 5. Drop the 4. And when you add 5 to both sides, you should get x equals 3. You try to see if you can do 13 by yourself. See if you got it. Mm-hmm. So for this one, you could use a base 4. Who used the base 4? Anybody go to a base 2? Okay. So you don't have to go to a base 2 because you can use a 4. But if you use 2, you still will get the same answer. It'll just be a little bit more work. So I'm going to keep it with the base 4. 4 to the what power is 64? 4 to the third. So then that gives you x plus 3 equals 3 times x minus 3. Distribute the 3. Subtract the x from 3x. Add the 9 to 3. And you should get 6. Who got 6? All right. Number 14, go ahead and work that out if you haven't already. So the biggest mistakes, I'm trying to think back to last year or just in general, because we do cover this in Algebra 2. One of the biggest mistakes is forgetting that you have to distribute the 3. So a lot of times students will take 3 times x but forget to multiply the 3 by the 1. Or they won't put it in parentheses and just be 3x plus 1. So just remember when you do change the base, that you do need to distribute that exponent. I'm trying to think. That's usually the only mistake that I see on questions like this, though. I think generally kids I mean, this is pretty. It's on the easy side, I would say. Especially if you know how to solve equations. So then you would subtract the x. And then I subtracted the 3. So I get -4. Who got -4? All right, we got one last question, and then that's it for today. So for this one, because both sides, we are going to have to change both sides. There's a couple different ways we can do number 15. Okay, so the first way to do this, first of all, does anyone recognize what the base would have to be? What'd you say? 3. So we have two different options. We can change both sides to a base 1/3, or we can change both sides to a base 3. If we change both sides to a base of 1/3, then we won't need to make the exponents negative. So 1/3 to the what power would be 1/27? 3. And then 1/3 to the power of 2 is 1/9. So this is the first way to write it. The second way would be to change this to 3 to the -3 equals 3 to the -2. Now, both of these are going to give you the exact same answer, because 3 to the power of -3 is 1/27, and 3 to the -2 is 1/9. So you have two different ways to solve it. You get the same answer. So pick one and go ahead and solve it for x. So I would probably pick this side because it doesn't have the negative powers. So 3 to the power, 3 equals 2 times x plus 4. Distribute the 2. Subtract 8. And then divide by 2. So you get -5/2 equals x. Now, if you did the left side or the right, you would still get the same result. I'll go ahead and work it out. -3 equals -2 times x plus 4. -3 equals -2x minus 8. Add the 8. And you get 5 equals -2x. Divide by -2, and you still get the same thing, -5/2. So you have two different ways to get to that result. All right, so tomorrow we're going to graph exponential functions, and that's it. Everybody got the quiz review, right? Everybody got it? Okay.